You select which one you want to look at. Makes it a lot easier that way. Okay?
We used to do otherwise like time. We used to try to guess the time.
Exactly. Yes, that's what you had to do before. You guess what time you want to do, and switch it back to temperature. Yeah. This way you don't have to worry about it. If you have that marked cycle, you can say, all I want to do is look at this cycle. Okay? So that's why it's good to use the templates and then go to, all right? Now, once you get to know the software, you'll be putting those marked cycles in there yourself. The only other thing we have in here is the post-test. The post-test condition is when the run is done, what temperature do you want it to go to?
Oh, okay.
Okay? Because sometimes you may, see we have it default to 40 degrees, between 35 and 45, all right? Sometimes you don't want to load a sample at 40 degrees. You might not want to, right, with your water sample.
Yeah.
So you may change this to, you know, between 20 and 30. So it loads it at 25 degrees, okay? There's two different options with that, okay? This is after a run, it goes to this temperature, okay? There is another option which we call standby. So if you go to the tools and instrument preferences, you'll see that we have a standby temperature. So what it's going to say is remember I told you that we turn this RCS on through the software. When you come over here to control, you'll see the option for event.
Oh yeah, event on. Yeah.
Okay? That's all you have to do is turn that event on. And that turns that refrigerator on. And you'll hear it come on.
Yeah.
Okay? Wait your 30 minutes and you're ready to go. But when you hit that, you're going to see something that comes on and says, please turn on the standby temperature. Oh. So that my cell doesn't come crashing down to minus 90 degrees, right? We want the cell to sit at 40. Okay? So that standby temperature, same thing, you hit control, go to standby, and that standby temperature is set at the 40 degrees. So that's the difference between the two. Okay? After a run, goes to one temperature and the standby temperature. All right? Yep. So you can change both of those. All right? We default to 40 because that keeps the cell the driest that way with that refrigerator on. All right? You just got to remember you may not want to load your samples at 40 degrees. So you might cool it down some other way. Because what you can do is you can come here, just the standby temperature, and turn it to 25 and then say, go to standby temperature. It just makes the next person knows that they want to change it back to 40.
Yeah.
Okay. All right. I showed you briefly what, you have these drop downs here. As far as calibration, I think I did mention that the calibration is in our help menu, step by step on how to calibrate it. Very, very simple. If you go down here, you have so hopefully you're always going to be in the experiment, okay? And if you come down here to the calibration, then you can do calibrations in this field, all right? And then when you calibrate it and everything's hunky-dory, you come back to the experiment and you're ready to run all your experiments, okay? But what you do for calibrations with this is you run a baseline calibration. So I ran it from minus 90 to 400 degrees, all right? And what we do is we just see the baseline, we shift it. That's all it does, okay? Although other instruments do a lot more, this just shifts your baseline. Then you do the Indian, okay? If it's not melting at the right temperature, do a temperature calibration, okay? But all that is spelled out in these help menus here. As a matter of fact, I might have to change something in here too. That's one thing I'll change that real quick. I know it's not hooked to the internet, but we go through the Internet Explorer DLLs to bring up your file. If we cannot bring those up, okay, let's see here, options. So what you want to do is you go to privacy. See, the pop-up blocker was on, and then we want to allow active. So when we apply these, once again, when you turn the computer off and back on, then it'll apply it, okay? But we'll probably see that we can't, we probably can't get to the help topics right now until we shut that down. All right, it came up, okay? So here's calibrating the instrument, step by step on how to calibrate the instrument. The good thing is you'll find that you don't have to calibrate this instrument.
Okay.
And like I said, maybe once a year. Whenever I'm on, I'm in Greenville all the time. Pretty much all the time. So if you feel like you really need to calibrate this thing, and maybe you're talking to me or somebody from the hotline, if I have the time, I come by and help you with that if you have any questions. Okay? But it doesn't need to be calibrated that often. That help menu is also on the desktop too, if you can't get to that. So TA Q-Series manuals and TA help.
Okay.
Right there. Okay? All right, so now I've got my run going.
Yeah.
All right, my run is done. I have to analyze that data.
Yeah.
Okay? Analyzing is in WinUA, we call it, Universal Analysis. Okay? You have an option to get to it here. You also have an option to get to it on the desktop, not that one. It's this Universal Analysis. This data analysis is for rheology.
Rheology, yeah.
Yes. Okay, so Universal Analysis. Here's a copy of the software, right here, the Advantage software. If you want to put this on a thumb drive or something, you can put it on your laptop and install the Universal Analysis on your laptop. And that way you can take the data and analyze it on your laptop rather than tying this computer up.
We have it on our
Okay, good. Very good. All right, so now
Yeah.
we click on the Universal Analysis.
Yeah.
We open a file. So here's my Indian check that I did. So if we just double click on that, you have chances right here to change any signals that you want to look at. All right. If you make a change here, say, oh shoot, I forgot to put the operator on. If you put this in here now, it's only a one-time deal. Okay.
Oh.
If you bring this back up, that's
It'll
not going to
go.
be there.
It
We didn't
won't
make it
save
that
it.
easy, right?
Okay.
That's too easy to do.
Okay.
So you say okay here.
Yeah.
See, we have this nice Indian file. Hopefully all your samples will look like this. So if I want to analyze this and integrate this peak for this melt, very easy. There's several ways of doing it. You have a icon, and if you leave the cursor over the icon long enough, it tells you what it is.
Yeah.
Okay. You also have analyze, and you pick one of these. Okay. If you integrate the peak, you have different ways of doing it. Most of the time it's linear. Okay. And the third option is the right mouse key in the white space. You hit the right mouse key, and you have analyze, integrate the peak linear. There it is. You just pick your cursors. You can click on this and drag it to where you want to, or you can simply double click on each side of it. Once you're happy with that, you have two options. You can hit the enter, or you can hit the right mouse key and accept the limits, and analyzes the peak for you. And there's all kinds of the different analyzing that you can do. Glass transitions, peak max, things like that for all the analyzing. A lot of times what you have is you have, let's see, we have the test PET here. There's a PET sample, Coke bottle. So you have here's your startup hook I was telling you about, right? You want to make sure, we're always going to have that startup hook. That's the difference in the mass between the reference and the sample. So if you have 5 milligrams, you have this. If you have 10 milligrams, you have this. Also, starting at 5 degrees and 10 degrees will make that bigger too. So it always has to be there. So that's why you always want to start your runs, hopefully at least 20 degrees before you're expecting something to happen, some kind of transition. Okay? Now you won't be able to do that with your water, of course. If you have something at 30, well, yeah, we'll have 20 degrees then, because we get it to 10. So start at 10 and then go up. Okay? So this glass transition here, all you have to do is, again, you can pick from here, just both sides of that. And the only reason I'm bringing this up now is because a lot of times with these glass transitions, they're a lot smaller than when you get to a melt or something, right? So you can blow this up if you want to and have it on the same graph. Or you can do, blow up the glass transition, analyze that, save it, then, do your melt. But you can put this on the same graph if it's big enough. So if you click on this and you hit the right mouse key, you can do the inset view, and you can put the X and Y axis. You can draw an arrow to it if you wanted to. When you hit OK, what that does is it blows up.
This I didn't know. Yeah.
Yes, it blows up your signal and points to it, and that way maybe you can put them both on the same graph. You have your TG and your melt.
Yeah.
Okay.
Oh, this is neat.
Yeah.
This is good.
Yeah, very quick. Yeah, exactly.
Normally we do this in PowerPoint. Sorry.
Origin. Yeah.
Draw it in Origin, blow
Yes,
up,
yeah.
then mix it in PowerPoint and make one single
That's
image.
right. That's right.
Next time.
And then go to Photoshop to change the BPA.
Uh-huh.
Right? You have to use 4 softwares too.
That's right.
Nice.
So yeah, we have made that a little bit easier for presentation and stuff
Yeah.
like that too. Saving these files, there's different ways of saving it. You can save it as a file for bringing it up in Universal Analysis again, or you can save it directly as a PDF file.
Okay.
Okay?
And is there JPEG format?
Yes, you can do JPEG also. You can export the data, signals, or whichever way you want to do it
Yeah.
only, and you can select which way you want to do it. Ask it. Okay? If you have a question for me or the applications lab or something like that with this particular sample, if you can send us the run that we can look at in Universal Analysis, that's a lot better for us. Because if you send us a PDF file, that's all we look at is a picture.
Yeah.
But we can look at how you ran it and everything like that in Universal Analysis. And we swear, we're sworn to every secrecy. And plus we look at so many files we can't remember anyway. But if anything's proprietary or anything like that, don't worry, we're not gonna.
Okay.
If it is, just let us know.
Yeah,
that,
yeah.
Hey, this is okay. We won't let anybody know about this. We'll know for sure. But that's it in a nutshell for Universal Analysis too. Okay, it's very, very simple to use. Hopefully you will be using it in the next couple days.
Yeah.
Good. And then if you have any questions during that time, please don't hesitate to call on me.
Okay.
Like I said, I'm gonna leave plenty of cards with the hotline number too.
So can we load up multiple curves at a single time and compare?
Yes, I'm
How
sure.
do-
Yeah,
I never
you sure
learned
can.
that actually.
What you want to do is make sure you have those files open.
Okay.
So, so when you come here to the window, you'll see what files you have open.
Okay. Yeah.
All right. So have all those open. Then what you do is you come here. There's 2 different ways you can do it. There's a auto overlay.
Okay.
I don't like to use that one. I'd rather use the manual overlay. And you also have in here graph overlay, manual auto. Okay, so there's several different ways to get into different parts of the software. So we do the manual setup. The reason I like the manual setup is because then you get to add the curves that you want to. Okay, if you do auto, it's gonna
Just
put
take
all the
everything,
curves
yeah.
that you have open.
Yeah.
All right, so at least this way, if she had 3 curves open, you can do deselect those. All right, and then from here, what I can do is say okay. And now Windows doesn't let us automatically choose colors, but you can do auto color or you can choose a color from here. All right. You can also do just multicolor. Then you hit OK. It overlays those 2 folders for you.
Can you stagger it like
Yeah, probably the easiest way to do that is to click on it.
and shift it?
Yeah, and just shift it down.
Okay.
But then it changes your 0 and everything too. So
That's
if you're
okay.
starting at 0, that's okay. I mean, you in your presentation you can say that.
Okay.
For presentation purposes, I shifted this down. They were right on top of each other or something like that.
Just put a white.
I know, but this is still
layer on
handy.
the y-axis and say.
Arbitrary units.
Yeah.
No, this is good actually. Nice. Yeah. Thank you.
So that makes it. I mean, like I said, it's pretty darn easy. I can't think of anything else. I might think of something when I get down the road.
Okay.
If I do, I'll leave you an email. Oh, I forgot to tell you this.
Yeah.
Got
We'll
a
run
prepare sample, yes.
Also, this ballistic DSC you were mentioning, right? Do you think that's close to something like the injection molding process? Like when you open the mold, you have like a. First of all, what is is it like very fast cooling? Is that what ballistic is?
Ballistic means that, yeah.
Okay.
Ballistic is, but they're talking typically like 500 degrees per minute when you start talking ballistic. We can go 100 degrees per minute.
This machine.
Yeah, depending on what temperature you go to. So if I go to 400 degrees and I want to go down to 100 at 100 degrees per minute, I can do that. If I want to go to minus 50 at 100 degrees, no way.
Okay.
Remember, it's all depending on the heating or the cooling rate and how low you want to go.
So what if it's like room temperature, like 25? Can it go from 400 to 25 in that amp?
It'll get pretty close to that. Yes, with this particular system. Yep, sure can. The good thing is program it in there, okay? make sure you hit that equilibrate in there too. And you can always look at that rate also, okay? So any rate that you, or any program that you have, if you go here to your signals, you can always go to the temperature and the derivative of that. Oh, I'm sorry, chose the wrong derivative versus time. So I got the temperature and the derivative of that versus time. And that's going to give me my heating rate. Okay? So here's my heating rate here at 10 degrees per minute.
Is
So-
this analysis software only for DSC or can we do TGA as well?
Yes.
TGA also.
Yeah. It's universal analysis. So
Yeah.
anything we have, TMA, BMA, TGA, DSC. Yep. But not rheology. Rheology
Yeah.
is the data analysis.
Yeah.
Yep. Okay, so you would look at that in your cooling
Okay.
to see if it achieved that 100 degrees per minute
Oh, okay.
and how far it got down to.
Nice.
Okay. All right, preparing a sample. I'm gonna steal these tweezers.
Actually, can we set this up here? I think that's where Dr. Pilla wants.
Okay.
I'll just clean it up. I think this is for geometer, right? Can I put it here? Down, right? Oh. Not wanting to go down.
Only give it can.
Lower the. Yeah. Oh. Do you want to zoom it? Is this better? Okay, yeah.
Okay. First thing I'm going to say is that we have several different types of pans that you can purchase from TA Instruments using the DSC. Okay. The good thing is that every single pan that you order comes color coded. These color codes represent what dyes you can use in the press. Okay. So these are our T0 pans. All right. This is what came with your system. These are our high sensitivity pans, okay? They're extremely flat on the bottom. We make sure that our vendor, whoever makes these, makes them very, very flat, okay? And the good thing about these is no matter what sample you put in there, that bottom remains flat, okay? That's the most important thing when you put it into that DSC cell, is to have a nice flat bottom. If it's curved or concaved in any way, deformed, you lose sensitivity that way, okay? So these are the pans that come with it. And you can see that you can use either with these pans, the black dye or the blue dyes. All right? So the bottom, where you put your sample, you can use either one of those dyes. And I'll get to which one they are, and the difference between this one. So here's my T0 standard lid, okay, black. So if I wanted to use a sample that's a film or something like that, I'd use this pan and that lid, okay? And what it does is you put your film inside the pan, you put your lid on top of that, and it just presses it down. Keeps the sample contained in that area, okay? If your sample foams up or expands in any way, it could push up that lid, okay? So that's the black. So that's a perfect sample. Indium is fine. No matter, it's probably like 80% of our samples are fine with this, okay? Now, there's a blue lid. So here's blue, okay? So that blue would go with that pan. This is what you're going to probably use with your liquid samples.
Yeah.
Okay? This will hermetically seal.
Hermetically seal.
Okay? And you use the blue dyes for that. Okay? So first you distinguish which die you want to use, or which pan, and then you correlate that die with it. So say we're going to use the hermetically sealed one, okay? You find your top die first, which is the blue. This is magnetic, so you stick it in there, and it stays up there. You take this die, and then probably what you want to do when you get your microbalance, the easiest thing that I found is you go ahead and tear these two items out, okay? Go ahead and put your sample in there, crimp it, and then put it back on the microbalance, and that's your sample weight, okay? So, and the way that these pans go on, and I'll prepare one because this can be your reference then. I'll try to stay out of the way. I always close these because you spill them one time.
Oh, yeah. It's tough to pick it up again.
Yes.
There might be some dust in it or something, yeah.
And notice the other thing, just like always using the tweezers for the lids, I always use the tweezers for these too, okay? And try to set them on a nice clean surface. Oh, one dropped out there. So this lid, right on the edge. The lid actually goes on like this for the hermetic, okay? For the standard lid, it's going to go this way. So this one we're going to form like a cup like this. The other one we go down. Okay? So that's the big difference between these. So you take this, put it in here. I didn't have 3 cups of coffee this morning. You know what? I'm sorry. That's our old pipe. Forget